Can? Joshua? Can? Oh, okay. And so the last part for today is parametric differentiation. Janessa, if you need to look up English, look up. Just now I already say dy dx. This is what? This is right. dy dx is equals to dy dt. This is a bit like a rate of change kind. So if you want to do implicit differentiation, always write at the top first, or dy dx equal dy dt divide by dx dt. Why? Because if you go and flip the divide, right, to become times, this will become dt dx. And then you cancel, they are mathematically equal. Understand? Okay, so how do you get dx dt from here? Can you see? Because parametric talks about 3 types of variable, x, y, and t. Okay, so if x, you differentiate x with respect to t, it's called dx dt. Understand? Equal 3t squared. Okay, dy dt. Shen, tell me what is this equals to?
2t minus 1.
Yeah. So what is dy dx equals to? Be careful. People like Jalen is going to get careless. He's going to use 3t squared divided by 2t minus 1, right? Yeah, then it's better you write down, or is dy dt. The dy must come first. Divide by dx dt. Okay, Jalen, tell me the final answer. And that's all. That's all. Yeah. In differentiation? Don't think so, because it's been taken out already. Last time, yes. Yeah. Show me the limits in school notes. From what I know from other schools is using the first principles to find out, right? It's just good to know basis. Don't have yeah, not important for now. Understand the application. Let me see your tutorial get got not. Don't have what? Or by considering the derivative as a limit, right? Okay, so it's okay because I just took out from my notes only. Okay, the thing about limits. Okay, so parametric is the question is okay. This is differentiation in the first principle, which is in your notes. How to understand this? So the question 2 of your tutorial, they say that show that the derivative of x cubed is 3x squared. Okay, can? Now, so look here. This part about first principle, right, is see whether you understand what is the meaning of dy dx. Okay, so what is the true meaning of dy dx? Dy dx equals to a gradient function. Okay, what is the meaning of gradient function? What is the meaning of gradient? That means it is y2 minus y1 over x2 minus x1 of a curve, right? Okay, so you must understand that. Okay, so this is going to be a gradient function. Okay, so how to do this kind of question is, now y equals to x cubed looks like this. Okay, and I put a point here and label this as x. Okay, so this guy will be called x comma x cubed because it's called y equals to x cubed. Understand? Because this graph is called y equals to x cubed, right? The y is x cubed, right? Okay. Now, suppose I have x plus h type parts away. Okay. So which is going to be here. Can I say you're okay with this? You get. Okay. Then the x coordinate is called x plus h. The y coordinate is called what, Josh? No, x plus h, the whole thing cube. Understand? Understand? Because y equals to x cubed, lah, bro. if the x is x plus h. Outside lah, then x plus h the working cube. Yeah. Okay. So dy dx equals to, write down, I am trying to minimize the h. Limit as h approach to 0. Because I'm trying to minimize the h. I had a video on this because last time it was in the syllabus. When I want to, basically I want to bring the x and x plus h, right? So close that you cannot even see. Understand or not? Like I'm supposed trying to bring the x, let's say this is a zoom out version. If you zoom in, right, then x plus h like is here. Can see? I want to bring this guy over here. That's why I want to minimize x plus h. To minimize h means I let the space between the two of them, right, be very close to 0 such that it's negligible, but there is still a space. Okay, use this y2 minus y1. So this will be x plus h cubed minus x cubed over x plus h minus x. Okay, still keep the limit as h approach to 0. Okay, open up the top, the x plus h cube is equals to x cube plus 3x square h plus 3 choose. Key for me 3 choose 2 is what? Somebody key for me 3 choose 2. Okay, never mind. Yeah, x h square plus h cube. Okay, so this I'm using binomial. Of course, you can just expand it slowly yourself. X cube plus 3x square h plus 3xh square plus h cube over the denominator becomes what? X plus h minus x. H, yeah. Okay, the limit is still there. H approach to 0. Now you divide. X cube over h plus 3x square plus 3xh plus h cube. Anything as h, this one will be 0, 0, 0. What is the final answer? Wait, where?
The last one is h cube.
Yeah, h square. But anyway, it doesn't matter. What is left?
3x.
3x squared. Which is the differentiate. Yeah, which is the divide dx. Battery, no? You don't have battery. Understand? So this is the real meaning. That means you label 2 points. One is when x, one is called when x is x plus h. Then just put in the y value. Okay, then use gradient function or y2 minus y1 over x2 minus x1. But where does the limit comes in? Is because I want to bring these 2 points so close to each other that you cannot even see. Understand? That's why we use limit. Not very important. If come out, just do others lah, do the vectors lah, or do the APGP, do the functions. Understand or not? Okay, not really important. Oh yeah. Yeah, so no wonder. So that minus x cube, right? Yeah, so basically there's no this. Yeah, there's no this. There's supposed to be minus x cube. How differentiation is in the most old ancient times. Yeah. Understand? Okay. So I'm going to also talk about your differentiation tutorial, question 6. Is it question 6? Question 6, right? Let's see.